Hey guys, Mr. Catlin here, and we're doing lesson 5 from our practice problems this week. And the first one is just a bunch of unit rates, which is a concept from 6th grade that you are carrying over to this year, as we're calling it the constant of proportionality, or the price per one, which is what we're going to be finding. So what did these people pay per 1 pound of each of these items? And we're giving a price per different amounts of pounds. So to kind of relate this to what we've done this year, you could think of part A as being a table, and you're dealing with money compared to pounds. And $5 is how much you paid for 4. And so what we're trying to find here is how much are you paying for 1. And so it's a question mark. And that number is always going to be the money divided by the amount. So in every one of these problems, you're going to be doing the money number divided by the amount of pounds. So like in this first one, you're going to be doing 5 divided by 4, which is the same as 5 quarters, or $1.25. So for part A, you're paying $1.25 per pound with that particular one. Okay, so all of these are division problems, so let's knock them all out. Part B, $3.50 divided by a half. So if we take $3.50 and we divide by 1/2, that's the same as keep, change, flip. It's the same as $3.50 multiplied by 1/2 reciprocal, or 2. So that's going to give me 7. So you're paying $7 per pound if you're paying $3.50 for a half. Double it, you find out you're paying for the full pound. The next one here, C, is 8 1/4. 8 1/4. I'm going to write it like this: 8 1/4 divided by 1/2. Divided by 1/2. So I'm going to go old school on this one. Go around the world and change these into impropers. 8 times 4 is 32, plus 1 is 33 quarters. And then 1 times 2 is 2, plus 1 is 3 halves. So this is what we're doing. Keep, change, flip. This becomes the multiplication problem of 33 quarters times 2/3. The 2 and the 4 there can reduce, and 3 goes into these once and 11 times. So you get 11 in the numerator, 2 times 1 on the bottom, 2. So 11 halves. And if you cut 11 in half, that's $5.50, or 5.5. So for the coffee beans, you're paying $5.50 per pound on those. And then on D, let's do that one right here. D, we've got $6.75. So I'm going to write it as 6 3/4. And we're dividing it by 3/4. So we're thinking, how many times can 3/4 go into 6 3/4? So the way that I'm going to think about this one is 27 quarters multiplied by its reciprocal, 4/3. 4's go away. 3's are nice factors of 3. And we get 9. So that one is $9 per pound. Not the most expensive for the fudge so far. And then the pumpkin. So part E we'll do right here. 5.5, $5.50, divided by 6 1/4. 6 1/4. 10, 11 over 2, divided by 24, 25 quarters. Keep, change, flip. 11 halves times 4 25ths. We can only change these. 2 goes in that twice. So we get 22 over 25. This one is the least expensive. We can multiply both times 4 to get this out of 100. So it would be in cents. That times 4 would be 88, or 88 hundredths, which was 88 cents per pound. The cheapest, for sure, is the pumpkin, as they are big but not very pricey. Finding the products on number 2. So a lot of this is a recap of things we've done in the past to kind of get you started on your homework. Multiplication of fractions: a positive times a negative is negative. And 2 times 4 is 8. And 3 times 5 is 15. No common factors there, so that's pretty simple. Negative times a positive, once again, is negative. The 7's here will cancel to 1. And the 5's will cancel to 1. So really, this is the same as 1 times 1. So you get negative 1. You already have a negative there, negative 1. On the next one, think of this as 39 over 1. And the 39s are numerator and denominator, so they cancel to 1s. 2 times 1 is 2, and 1 times 1 is 1. And a negative times a positive is a negative. So you essentially just get negative 2 there. And then on the last one, a positive times a negative is a negative. So you get a negative. And 2 times 3 is 6. And 5 times 4 is 20. That does reduce to a smaller version. Half of 6 is 3. And half of 20 is 10. So just a little review on some fractional work there. It can't ever hurt to do those kind of things. 3 and 4 actually relate to what we've been talking about the last couple of weeks. So let's jump into those. Those are the most important. Family buys 6 tickets to a show. They also each spend $3 on a snack. Keyword there being each, as it's italicized. They spend $24 in total on the show. So let's do a tape diagram for this, and then we'll match it to the correct equation. Okay. So on the whole show, they spend a total of $24. 6 tickets, and everybody gets a snack. So that means everybody is spending the same amount of money. So I'm going to set 6 equal parts, and 6 equal parts of everybody buying a ticket and a $3 snack. We don't know the ticket. We'll call that X plus a snack of $3. So X plus 3 would be what this would look like for every person, the price of the ticket plus the price of the snack. And that matches 6 groups of X plus 3 matches this one. So this story goes with 6 times the quantity X plus 3 equals 24. Which means Diego's problem must go with the other one. Let's see if it does. Diego has 24 ounces of juice. He pours equal amounts for each of his 3 friends, and then adds 6 more ounces for each of them. So that makes sense that for this one, the 24 ounces is being divvied up amongst 3 people, thus 3 sections. Everybody got a certain amount of juice, and then he goes back and he adds 6 for everybody. So that would look like this, and essentially the 3 and the 6 traded places in story 1 and story 2. So that's why this one matches 3 groups of X plus 6 to get to 24. Now, it says which equation represents which story. Check, we've already shown that. What does X represent in each equation? Okay, so let's go back to the blue one up here. In the family story, X is representing how much we paid for the ticket, so it's the price of the ticket plus the $3 for the snack. And in the second problem, X is representing juice and how much he initially poured. So initial amount of juice. And then he went back and added 6, right? So that's what those represent. Find the solution to each. All right, so let's find the answer to each of these. This one, we'll start with the blue one up here. If 6 X plus 3 is 24, then a single X plus 3 would be equal to 24 divided by 6, which is 4. And for that to be equivalent, X would need to be 1. So for the first one, X is 1. And for the second one, let's work that one out right below it. If 3X plus 6 is 24, then that means that a single X plus 6 would be equal to 8, because 24 divided by 3 is 8. Hence, that X, or the amount of juice he put in everybody's cup to start, was 2. And then, so we're showing our reasoning here. What does each solution tell you about its situation? It tells me it gives value to our unknown, our variable, our letter. That's what it does. Okay, last thing. I give you the diagram. I give you an equation. All you have to do is use a strategy to find the solution. So we've got 6 groups of 1, 2, 3, 4, 5. 6 groups of X plus 1. So X plus 1, or a single X plus 1, must be equivalent to the 24 split into 6 groups. So if 24 was split into 6 groups, every one of these would have a value of 4, because 4 times 6 is 24. So X plus 1 must be 4, and hence X is 3, because 3 plus 1 is 4. And there you go. There's your first page of your homework completed, and we'll have the other videos posted later this week.